This video is the final project of my construction management experience at Snow College. The construction methods and materials used in the development of the fixed heliotropic hot water heater are applied to the creation of a multiple-use facility in a limited space. The design concept is my original idea. I have used the idea to develop the practical application on how the system will integrate with the traditional building process. All considerations were given to create a multiple-use facility, which focused on self-sustainability. Using limited space of a mini-home philosophy, the design includes a solar hot water heater, kitchen gardening, food production, a freshwater cistern, and multiple-level art studio and wellness center.
Hi, my name is Tom Morse. Nikola Tesla studied the natural harmonics of the Earth's energy. He developed the vortex code that mathematically described the patterns, these natural patterns, in groups of 3, 6, 9. It's very similar to the fractal geometry that has infinite. This model for the fixed heliotropic hot water heater uses the same patterns with the 3 containments, each containment having 6 panels, and then the 9 panels on the top gathers the sun's energy and directs it into the center of the device. And it reflects off the 3 panels inside that directs all the energy into the center of the piece as the sun. Now the question is why is this piece in an art show? Granted, it's an architectural model, which, okay, that suffices. It's also a mixed media sculpture, and that would be for sculpture. But the real reason is this is a conceptual piece, because if it can be built to scale as it is, then an individual can move within this space, within the light that it creates throughout the system. That makes it conceptual in nature, where you're actually living inside the art piece.
This facility would outwardly appear to be a sustainable test site for a residential holistic health center. The practical aspect of the mini-home design is masked by the philosophy and behavior psychology of living and working in a conceptual art installation. Personal space within the structure is promoted with the use of levels and enhanced perspectives to extend the confines of the physical environment. Each level is further enhanced by integrating high-resolution graphics, mirrors, and angled acrylic walls that focus the light to the center of the solar containments. The design calls for internal copper piping that is coated with copper oxide for best energy absorption. The hot water pipes for each cell are also fashioned like the wings of an aircraft. The skins of the containments are stretched over the piping, which provides strength and weight reduction for the system. Yet it is the pipes themselves that provide the storage for up to 50 gallons of hot water. In addition to the subsurface installation, the test site would be heated and cooled using a passive geothermal system and radiant heat piping. The use of lightweight construction materials will further reduce costs and provide an installation capacity that can be measured and reproduced in similar construction projects. Some of the elements that are included in the system are a meditation studio, an enhanced perspective presentation area, a hanging garden that is also can be used for kitchen gardening and producing food production, a solar still for water purification, and what appears to be an elaborate cascading water element. In reality, this water element is part of a water storage system and water reserve for the greenhouse. Another element of interest is the dome-like structure on top of the FH3 solar installation. It is a ram air fabric wind turbine that will produce enough energy to charge the operating pump. The precise measurements allow the lightweight materials and elements to support each aspect of the integrated structure. The combined assembly may flex and conform with the natural forces in and around the structure. However, the strength of the concept comes from the symmetrical design and the smooth transfer of energy within the system. This construction process itself capitalizes on this synergy. This view of the northwest elevation, top view of the tower roof gable, shows the synergy. But it also shows how the gable roof is skewed a little to provide maximum exposure to the containments. This is the northwest rendering. The integration of the test structure also defines the architectural relationship of the multipurpose venue. Each of the cells of the solar containment group is supported by the two other cells. They are positioned to collect and absorb the maximum solar energy. Even the containments positioned in relation to the geothermal greenhouse provides retention of solar energy. Working as a cohesive unit, the lightweight materials enhance this process and make best use of the support configuration. As we think about the estimate, how much it would cost to build this system, I had to break the estimate down into three groups. Acquired materials, the tower construction, which is the traditional building materials, and the three is the containment fabrication. Using acquired materials help us in the bidding process by the availability of materials, the cost of materials, and anything that we can gather on our own would reduce that, and it gives us a flexibility for the bidding process.
As we look at the architectural model for the fixed heliotropic hot water heater, building the model in scale allows us to walk through the spaces to identify problems in the design manifestations. The design itself is a conceptual art piece where an individual can move in and out of this structure freely. Now, normally that would just be normal business practices. But as we're dealing with methods and materials for this development of this fixed heliotropic hot water heater, we're focusing on not only the materials of traditional construction as we see here in the scale model, but there's also an added interest in this, and that is that this is a non-traditional building methods and materials. The containments themselves for this fixed heliotropic hot water heater is designed to pull in the natural sunlight and distribute this natural light within the system itself. This gives us an opportunity for designing this and implementing this for a wellness center, for a conceptual art piece. But there's another aspect to this, and this is wellness. If we're in a very comfortable place, even though it's small by scale as we move through it, but if we can feel comfortable in a smaller place, then this similar design can be used for building mini homes for the homeless, or more importantly, how we can learn together to build more efficiently and more adequately with the spaces that we have available. This is what's unique about this is the materials that are used for the containment. This could either be tempered glass, but it can also be polycarbonate that's formed with a vacuum form to create not only the rigidity for the wind capability, but also to utilize the space in the best way possible without over-engineering what needs to be built. As we can look at this in this view, I'd like to point your attention to the staircases. These staircases are to scale. There's 10.5 by 7 inch tread and riser. And then the handrails are, according to code, 3 feet high, 4 feet landing. And that gives us an area up here, approximately 9 feet by 9 feet for an observation deck, a mezzanine if you will, which will allow us to do maintenance on the system inside. This will also give another interest in, because of the levels, it gives us this opportunity to use levels in different ways to break up the space so it's not confined like a box. This in itself will add a great deal of wellness, to the inhabitants of this fixed heliotropic power water heater. Spatial relationships is interesting because each one of these containments are 17 feet tall. So you can see that, yes, this is a massive thing, especially caught by the wind. But if we use modern building techniques like guy wires to support the method, and also foundation with the cement forms that are used. The other additive thing is by using insulated cement forms and a 2-foot insulated skirt, we can save on cement costs for the construction of the material. This kind of concludes the project as far as we have at this point. And I want to thank Snow College Construction Management Program for allowing me to bring this project this far. Hopefully we'll be able to build it in actuality and put it to use as part of a wellness center in the future. Thank you.